Hello everyone, welcome to our presentation on Pseudocode by Tess Arcade, Avery Webb, and Jefferson.
Pseudocode is detailed but readable code that's in a natural language. It's writing what your program will be doing in words that most people would understand, even if they have little or no coding experience. Pseudocode is written before coding takes place. It's a way for developers to design and determine how the program will function without completely coding it out. Pseudocode is a logical progression of each step that the program will take and how it will handle each event that the developer anticipates. There are many different ways of writing pseudocode. Some people have distinct preferences of how they believe pseudocode should be written, while others tend to defer to the individual's preference. Technically speaking, there is no universally acknowledged way of writing pseudocode. There are, however, recommendations on how it can be written. Overall, the most important thing is that you walk through the code and write down what it will be doing. This will help you determine what you're actually going to be coding and how the code will look before you get to the coding process. This helps you save time and effort when you actually code because you've already written down what it should be doing. So coding, in essence, is easier after you've written pseudocode. True to its name, pseudocode is like coding, in that the logic is evident and similar coding terminology can be used. When writing pseudocode, it's helpful to readers, and possibly yourself, if you use typical coding spacing. This helps to define code blocks and keep the pseudocode organized. For this example, I've taken the TDL app's new or returning user process. In the example, you'll notice that I've included some code in shorthand, and not just straight English. Brackets are also employed to help with organization and keep individual parts separate. In the example, we first determine if it's a new user or not by using an if statement. If new user equals true. If that is true, we prompt for the new user information that we need. If it's not true, the else statement, we redirect to the main menu. This line of logic continues along through nested if statements to verify that the application asks for and gets all of the information you're expecting. There are additional if statements in here that go through the rest of the process, and if you'd like, take a second to look through those and try to determine what we're telling the TDL app to do using pseudocode.
There are a lot of advantages to using pseudocode. Pseudocode is a powerful tool that can help students learn the principles of software development. It helps students separate the principles behind the code from the syntax of the actual coding language, which is often very confusing for beginners. This allows the students to more fully understand how the code actually works. Because pseudocode is language independent, we can write pseudocode and then apply that pseudocode to any programming language. This also enables us an easier way to transfer code between different languages. Before coding for a project actually starts, pseudocode can be used to test many different approaches on a given problem, to see which will be most efficient and maintainable without spending needless money and time programming each option. Pseudocode is also helpful to making sure that a design will work in theory before coding actually begins, and it will help catch potential errors before time is wasted following a wrong path. Now that we have talked about the advantages of using pseudocode, we need to discuss the downside of using pseudocode. First, there is no standard way of writing pseudocode, so everyone will have a slightly different way of doing it, and some will be much more helpful than others. There is also no way of executing the code, so we don't know if the code will actually work. This is especially hard to get used to when we are so used to getting that instant feedback from a compiler when we're dealing with actual code. Pseudocode also adds overhead to the development process, which sometimes this will cut costs for future development substantially, but other times it's just useless work that we're adding to the process, so we need to be careful about that. There's also the possibility that we could spend far too much time writing highly detailed pseudocode, which is simply a waste of the developer's time when they should have just started actual coding. Another thing is we need to make sure that we aren't posting the pseudocode as inline comments, because this is a great way to cause over-documentation, which we should not do.
As I was researching pseudocode, I found that there's a lively debate about which is better, pseudocode or flowcharts. While this is a presentation about pseudocode, there is another one in our class about flowcharts, so I'm not going to take sides. I will say that in the article referenced on this page, they quoted some studies that found that flowcharts were better, and other studies where pseudocode was considered the stronger choice. You can see this in the two quotes I pulled from that same article comparing the two. I also found multiple images of flowcharts versus pseudocode. Some made the flowcharts look much better and the pseudocode more complex. Yet others did exactly the opposite and had very complex flowcharts and more simple pseudocode. I included one here that I thought did a good job of representing a simple problem that could easily be solved by either a flowchart or a pseudocode. In the end, I think it depends on what works best for you. If you are a more visual person, you may have a preference for flowcharts. If you are a more verbal person, you may find that working with pseudocode is better. Chances are good that if you go on to be a professional software engineer, you will find times where you will use both. Pseudocode should describe what a design is doing, and not exactly how it's going to be implemented. Pseudocode should contain precise natural language descriptions and specific actions, as Tess demonstrated before. Pseudocode is most effective when used early in the development cycle, when a developer is still trying to scope and understand how to solve specific problems. Just like many writing instructors will tell you that it's better to get your thoughts on paper first, and then to go back and add formatting and punctuation, you can think of pseudocoding as another example of this style. First, you need to work on the steps and processes needed to solve a problem. Then go back and add the coding language syntax and constructs. Therefore, pseudocode is used to create the set of steps and actions that will comprise the structure for your algorithm and create the solution for the problems you've identified. Finally, pseudocode is very useful to explain complex algorithms to non-technical people in a presentation or paper or article. However, having said all this, based on RTDL application, we see little advantage of adding pseudocode to our SPD document. More likely, an engineer would take our document as input for pseudocode as he or she was working to solve the problems presented in the paper. Thanks for listening to our presentation. Hopefully you've learned a little bit more about